Cool, yeah, thank you very much. Kind of an odd topic for a keynote, I guess. It's not going to be some philosophical looking into the future kind of stuff. It's going to be fairly practical. It's also going to be a bit of a sprint. We've got 45 minutes and there are 116 slides. CSS for software engineers, for CSS developers. Kind of a recursive, unusual title. What we're going to be looking at is how we can take CSS development, write it from the point of view or the context of a programmer, software engineer, computer scientist, and then reapply that work directly for ourselves. So we're not writing CSS for software engineers, we're writing CSS from the point of view as a software engineer for ourselves. How can we take paradigms, design patterns, established techniques from the world of traditional computer science, and just apply that to the CSS that we write daily? So yeah, we're going to look at some very specific paradigms. Some of them fit quite nicely into CSS, some of them you have to kind of creatively shoehorn. But before we dive into those, I want to start with a real brief history lesson. And that history lesson starts with these two. That's my mother and father on their wedding day in 1984. It wasn't until I was putting together this presentation that I realized that my father looks suspiciously like the Unabomber. Right? If anyone remembers the Unabomber identikit photo, I have some questions about his whereabouts in the 60s. But yeah, these two, really important to me. They're my parents, of course, they're important to me. But they also provide me with a really obscure and rather kind of specific professional benchmark. That benchmark is based on the fact that both of these two were born in 1959. And as well as being the birth year of my parents, 1959 is widely regarded as being the birth year of the first modern programming language. Now, of course, that's a very contentious issue. What's the definition of programming language? The word modern as well, open to interpretation, but it's widely regarded as being a language called Flowmatic. And Flowmatic was developed between 1955 and 59 by a woman called Grace Hopper. Who's heard of Grace Hopper? Oh, that's the most hands I've ever seen. That's really good. For anyone who hasn't heard of Grace Hopper, I urge you, please, 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 just do a bit of research. An incredibly important woman. She did a lot of pioneering work at the very kind of early stages of modern computer science. A really fantastic woman, and she came up with Flowmatic. And the reason it's regarded as the first modern programming language, it's the first one that ran electronically, but also used English words to manipulate data. So it's the first programming language that actually looked like something we might use today. I've just said all of that. If anyone has seen any of Grace Hopper's archival footage on YouTube, anyone seen any of her YouTube stuff? The one where she explains how long a microsecond is? Anyone seen that? All right, it's fantastic. If you've seen any of that kind of stuff, you'll get the impression that Grace Hopper's got a really amazing can-do attitude. And nothing sums that up for me better than this. This is an excerpt from the Flowmatic Wikipedia page. Basically, she went to her managers and suggested this new programming language, and they just said, no, not possible, can't be done. Instead of Grace being disheartened by this and abandoning any attempts, she just rolled her sleeves up and did it anyway. And I think that's fucking awesome. I really, really love and admire that kind of dedication. So yeah, 1959, birth year of Flowmatic and my parents. This is the weird professional benchmark I was telling you about, this weird professional timeline that my parents have accidentally given me. In 1990, I came along, and in 1996, the birth year of my sister and CSS. I've given this talk a few times. My sister still doesn't know that that slide's in there. Yeah, this weirdly obscure and very sort of specific timeline helps put my work into context, right? I've been writing CSS for a few years. CSS is the same age as my youngest sister, but the first modern programming language is the same age as my parents. This gives me a real tangible, manageable timeline to look at when I put my work as a front-end developer into the context of computer science in general. This huge chunk of time, this sort of 37 and a bit years, is full of information, research into problems that had never even existed before. It's a huge chunk of wisdom that we can, as front-end developers, beg, steal, and borrow from. I've made no excuse throughout my career for the fact that I've just taken things that software engineers have done and applied it to CSS. And that's exactly what we're going to do for the next sort of 40 or so minutes. Look at specific principles that this rich chunk of history has provided, and update it, right? Bring it into the modern day and use it in front-end technologies. I often find that it's the last sort of 5 to 10 years, perhaps, that front-end development has been regarded as being complex, right? It's only in the last 5 years that we've worried about front-end performance or architecture or maintainability or scalability. These are problems that have existed in programming since the beginning, so we should steal and take as much of that as we can to make our lives a little more easier. First thing, the first principle we're going to look at is dry. Who's heard of the dry principle? Lots of us. Who's heard of the single source of truth? Slightly fewer. So dry, don't repeat yourself, is what you do to code. You dry code out. And as a result of doing that, we end up with a single source of truth. So I like to describe the single source of truth as the slightly more philosophical backdrop to the dry principle. The dry principle states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. There's a really important word on this slide which I've actually neglected to highlight, and that word is the word knowledge. We're going to look at some confusion around the dry principle in a second, but dry isn't about avoiding repetition completely. It's not about not repeating anything at all. It's about not repeating key bits of knowledge or information. It's a real subtle caveat or subtle nuance with the dry principle that a lot of developers kind of miss out on. Every discrete piece of information should exist once. You shouldn't need to make the same change several times. Any repetition is extra overhead. It's just more to work with. It increases cognitive overhead. Has anybody ever inherited a project where you make a change in one place and you refresh the browser and nothing's happened? Then you dig around for another 15, 20 minutes and you realize that, oh, I need to change it here as well, right? We've all had that before, I imagine. At its most basic, that's just annoying, right? Forgetting principles or quality of code, it's just an annoying way to work. So the dry principle isn't about performance, it's not about good quality code per se, it's all about making maintenance simpler, cheaper, easier. Looking at a real simple example, we've probably all seen CSS like this before. Simple utility classes just to nudge spacing around. The subject of utility classes is a complete other subject, but imagine we've got some, right? And we've repeated this 12 pixels 4 times. The problem here is that 12 pixels is knowledge, it's information. The reason we've used 12 pixels 4 times is because they all have to be the same value. It's not coincidence. 12 pixels is knowledge. It's probably to do with our baseline grid. The problem here is if our baseline grid changes to 15 or 18 pixels, we've got to update that in 4 places, which is simple enough at this point. But there's a worse thing that could happen. We could update it in one instance and leave the other 3 out of date. And we get these sort of disparities, this inconsistency. We need to move to a single source of truth. So super simple examples, just stick key bits of knowledge in variables. Leveling up a little bit, here we've got 3 completely unrelated rule sets. These rule sets do not have anything to do with each other. They don't care that each other exist. But we've got some thematic repetition. We've got these 2 declarations that need to exist side by side. We've got a certain custom font that has to have a corresponding font weight before it renders correctly. If we swap our custom font, we've got a job to go through and replace all of these and their corresponding font weights. This isn't very dry at all. Quickest way to solve this is to use an argumentless mix-in. Now, has anybody ever heard the saying, argumentless mix-ins are bad? Anybody ever heard that? Surprisingly few people. I've read that so many times. A lot of people claim that argumentless mix-ins are bad because they return the exact same CSS every time without any variance, therefore it's just repeating code. It's the opposite of dry. Completely not the case. Dry isn't about avoiding repetition in compiled code, it's about avoiding repetition in source, right? We don't want to repeat ourselves or risk sort of disparity and inconsistency. So even though this gives the exact same output as we had before, it still compiles to the exact same amount of CSS. This is all about saving maintenance. This has nothing to do with performance or file sizes. Dry is all about maintainability. Single source of truth then, like I say, a more philosophical backdrop. What we do is we dry code out. What that gives us is a single source of truth. Key data should exist only once in source, and this gives us much greater confidence. That $unit, 12 pixels, we can confidently change this in one place and know that it's going to propagate through everywhere where it needs to exist. A single source of truth just makes a system much tidier and nicer to work with. So recapping some of the confusion then. Dry in source, not in production. Do not worry about what your compiled CSS looks like in terms of repetition. It's not about avoiding repetition, it's about avoiding repeating work, right? This is all about saving maintenance overhead. Automation of repetition is completely fine. I'm not going to read this slide out, actually. I wrote an article getting into the real subtle nuance of this difference. These slides are available, so don't worry about scribbling that down. So let's look at some more confusion. We've got these strings here, or these declarations, sorry, font weight bold. It appears 3 times in 3 completely unrelated rule sets. This is completely coincidental repetition. I've seen a lot of CSS libraries and frameworks that make either gratuitous use of extends or heavy use of entirely utility classes, just to avoid repeating something like font weight bold more than once. This is purely coincidental. This is not a candidate for being dried out. To dry out this code would create really awkward relationships in our CSS. So if something's repeated entirely coincidentally, it's better just have it repeated. Going too far, trying to dry out every single occurrence of a string in a project, is going to create really awkward, cumbersome abstractions. So yeah, use a preprocessor. I mean, this is real simple stuff, but use a preprocessor to start abstracting things out into variables, repeat things via argumentless mix-ins, sassy copy and paste. We can actually abstract full design patterns out if you're using object-oriented CSS or a style guide. Avoid drawing anything that's completely coincidental. There's a really nice saying in computer science, repetition is better than the wrong abstraction. I would rather change that 12 pixels 4 times than unpick a 500-line mix-in that spits it out for me. Simplicity, first and foremost. Repetition is better than the wrong abstraction. Okay, who's heard of this one? The single responsibility principle. Cool, a few of us. Out of this entire presentation, I think this is the single principle that gives you the most bang for your buck. This is the single principle which gives you the most kind of mileage in a software product. It basically states that everything should do one thing only, and it should focus on doing that one thing very, very well. What this deals with is taking big monolithic tasks and breaking them down into smaller instructions. If someone gives you the task of build a house, it's a really confusing task to be given. Where do you even start? What you do is you'd logically break it down into, well, find some land, clear the land, build some foundations, etc., etc. It makes tasks and instructions much easier to reason about. We can study small, granular instructions in their own kind of context, and then we can put them back together and get very high composability. Now, there's a surprisingly good real-world example of the single responsibility principle, and that's actually Subway, right, the sandwich restaurant. It annoys me they call it a sandwich restaurant. There's nothing restauranty about it. But if you go to Subway, you seldom order an entire sandwich because you get presented with this. When you go to Subway, you are presented with the ingredients. This means you can put your sandwiches together in exactly the order and combination that you want. What Subway have done is taken the idea of a monolithic sandwich and broken it down into just small ingredients. We can still get the exact same results, but we get much more flexibility with it. So it's a surprising example, but Subway is the epitome of single responsibility. Every single ingredient is only tasked with doing one job. Each part fulfills its job very, very well. Its role is very contained, very well defined, and we can combine and compose and swap out and alter things on the fly. We can make very granular changes, and this gives us incredible opportunity and flexibility. So much so that you can actually make 6,442,450,944 sandwiches at Subway. All of them taste identical, but you can make 6.4 billion sandwiches just by being presented with the ingredients. This is astounding, and this is actually true. Someone actually took time out of their life to work this out. That URL at the bottom, someone shows you the numbers behind this, 6.4 billion different sandwiches, all because of the single responsibility principle. To take this forced metaphor a little further, we've got, again, this monolithic sandwich, which I think would make an amazing punk band name. We've got this monolithic sandwich, and we can't really do anything about this. If you're gluten intolerant, you're stuck with bread, right? If you are a vegetarian, you're stuck with chicken, right? You can't really do anything with this sandwich. It's very hard to break down and modify. Just by breaking this down into single responsibilities, we can get the exact same sandwich out of the other end of it with much more opportunity, with much more flexibility, and far more sort of configurability. I don't really like tomato, just get rid of it. This way of working means that we can get exactly what we want, or more or less, and it's entirely our choice. So the single responsibility principle leaves a lot of power in implementers' hands. So provide developers with the ingredients rather than the meals. They need to make the meals themselves. If you're working in a company or a team environment or an open source project, Try and expose the most granular things you can so that you're not being overly opinionated. More realistically, let's take a look at this bit of CSS. I'm sure we've all seen CSS like this before. There are a number of things wrong with this. First thing, it's called button login. We're describing a very specific use case here. We can't really use this for anything else. It's very unreusable. But the second problem is that we're mixing up our responsibilities. Another definition of the single responsibility principle is that everything should have a single reason to change. Currently, this has got 3 reasons to change. Button login has 3 different reasons to change. We've got base responsibilities, we've got structural responsibilities, and we've got cosmetic responsibilities. This entire rule set handles 3 different jobs. Simply abstracting this out into 3 separate selectors means that everything now only has 1 reason to change. We've got a base class, we've got a sizing class, and we've got a cosmetic class. It's a much nicer way of working. We can get the exact same button out the other end of it, out of the other end of this, but it's all optional. It's all far more combinable, composable, configurable. And then just abstract this even further, extrapolate it. This is how we get design systems. Again, this is becoming the norm in CSS, so this shouldn't be too unfamiliar. But the single responsibility principle ties in very nicely with the next principle. That is the separation of concerns. Who's heard of the separation of concerns? This is quite a common one. The separation of concerns, I actually learned a lot more about this than I realized when I did the research for this talk. The separation of concerns isn't, again, it's not necessarily about writing good quality code. It's not about performance or file sizes or any of that kind of stuff. It's about understanding and reading code, right? It's really, really interesting. There's a very, very eloquent, quite wordy, but very eloquent description of the separation of concerns on Wikipedia. Basically, what it deals with is we should be able to understand individual parts of a program in complete isolation. We should be able to study one aspect of a program without worrying about any other unrelated part. The example cited is something like, I should look at a program's syntax on Monday and not be interested in its performance or its features. Tuesday, I should be able to look at its features and not worry about the performance or syntax. Then Wednesday, I could study the program's performance without having to worry about its syntax or features. It's all about compartmentalizing what you have to worry about at any given time. So each thing responsible for itself and nothing more. We can study these features now in complete isolation. We can make changes much more safely. So the word safe pops up a lot in this talk. We can change things very safely because we know that we only need to worry about the one thing we're looking at right now. If you've ever modified a bit of CSS and also simultaneously been worried about how that will affect your JavaScript, that's because the concerns haven't been separated very well. So in CSS, only bind CSS onto CSS-based classes. Don't have JS-classes in your style sheets. Don't write selectors that look like HTML, so very nested HTML element-based selectors, because now you're just putting DOM information inside your style sheet. Controversial one, don't bind CSS onto data attributes. Don't bind anything onto data attributes. They are your data layer. They have nothing to do with hooks or JavaScript or CSS. And don't bind JavaScript onto CSS classes, because you can't refactor your CSS classes without risking breaking your JavaScript. In a little more detail then, the top example, we've all seen selectors like this before, right? Yeah, I guess the problem here is that this is an Araya role. This has nothing to do with cosmetics. It has nothing to do with visual appearance. This does not belong in a style sheet. This is information for assistive technologies and browsers to signify how a part of the DOM works. This does not have any place in a style sheet, because if we change the sort of assistive technology meaning of a bit of HTML, we shouldn't all of a sudden lose the look and feel. The second example, header nav ul lia. This is bad for a number of reasons, heavily location dependent, a very fragile selector, but also it's just loading our CSS with HTML information. We can't change our DOM structure without losing our styling. We have completely blurred the line. We are no longer separating our concerns. We can't modify one without risking breaking the other. The third one, many of you won't even remember this, but many moons ago, we used to actually use HTML to style itself. One of the main reasons CSS was invented was to separate these concerns. It turned out to be a very inaccessible, very unmaintainable solution. We actually used to use HTML to style itself. And finally, yeah, binding JavaScript onto styling hooks. That nav should be JS-nav, right? We should be looking in the DOM for a JS-specific class. Taking the top example a little further, we're building a nav, right? We're building a navigation pattern. And as responsible front-end developers, I assume we're all writing our HTML first. And then we move on to styling this bit of HTML, and we think, well, perfect, there's a hook already in the DOM. There's something already in the DOM that I can style up. I can style against that, and you end up writing CSS like this. This is bad CSS. It's just loading our CSS with DOM information. We're really tightly coupling the two. We can't refactor our DOM structure. We can't change the accessibility information of this bit of HTML without breaking these selectors. This is not the separation of concerns. The separation of concerns tells me that I can refactor my HTML without having to worry about my CSS. The proper way to write this would have been this way. Right? It's quite a departure. It's quite a departure. But we'll step through each reason for this vastly more verbose bit of HTML. The separation of concerns tells us that we should worry about one thing at once. So the first thing I want to worry about is, semantically, what is this part of the page? If style sheets fail to load, if search engines read this, if assistive technologies, if screen readers read this, what does this actually mean to them? Once I've made that decision, I should be able to forget all about it. I should be able to forget that I made that decision and move on to my next concern. In this instance, it's putting an ARIA role in there, right? I want to signify some more rich information to an assistive technology and tell them how this behaves. Once I've made that decision, I should be able to forget all about that and step on to my next concern, which is styling. It doesn't matter what semantics are being used. It doesn't matter what elements I used. It doesn't matter what ARIA role I have used. Right now, I only care about how this looks. And once I've done that, I can step forward onto my behavioral stuff. This allows me to combine and compose these things, study them in isolation. I should be able to read my CSS without having to worry about what DOM structure it uses. This just makes code far more maintainable, and it lessens the cognitive load of working with any kind of software. Some good examples of the separation of concerns. Unconventional one, grid systems, and I'm talking like div class equals grid. They're not very nice, they're not very pleasant to look at, but it really separates your concerns in that your components are now nothing to do with the layout of the page. As soon as you've got a grid system in the HTML, that is what handles the structure, and you can fill that with whatever you want. Like I say, very unconventional, not particularly nice way of doing things, but very pragmatic, and it means that my components are they have nothing to do with the structure of the UI. The other one, writing CSS in JavaScript. This is quite an interesting one at the moment. Writing your CSS in JavaScript breaks the separation of concerns. I can't change my JS architecture without having to refactor all my CSS as well. There's a guy called Keith Grant, puts this way better than I could. If in 14 months you find a new Vue library that you want to try out, you're out of luck. You'll have to invest a lot of time pulling styles back out of JavaScript and into style sheets again. By writing CSS in JavaScript, what we are doing is we're completely breaking the separation of concerns. We are deciding that our CSS depends on whatever choice we made for our Vue layer, our JavaScript architecture. Immutability then, the next principle. Who's heard of immutability? Oh, wow, loads of us, right. So this is really popular in the JavaScript and functional programming world at the moment. Immutability deals with mutations, or lack thereof. An immutable object is an object whose state cannot be modified after it has been created. So conversely, a mutable object is an object that after it has been created, we can manipulate it, change it, modify it. We can mutate it, basically. Immutability is really, really nice. Immutability, if things can't be changed after they've been created, gives us a much greater confidence. It means that whenever we observe something, we know exactly how it behaves. When we move it somewhere, we know exactly how it's going to behave. We've got a lot of confidence manipulating, debugging, reading, and recycling code. It removes caveats, states, and conditions. So any kind of caveat in software is just more cognitive overhead. If you have to remember that, actually, if this is here now, it means this, but if it's there, it means that. That's just a difficult, confusing environment to work in. This is why on large projects it's often advised to avoid the use of ems, because an em always has a different value depending on how and when you observe it. An em is a completely mutable state. Favoring rems and pixels is much nicer to get rid of that mutation. So look at some examples. You've probably all seen CSS like this before. Simple grid system CSS. Col6 is half the width of whatever parent. But then we get this fairly opinionated decision that at certain screen sizes, we're just going to collapse everything into one column. The problem here is we've mutated this class because col6 either means 50% or 100%. But it depends how and when we view it, what that value is, kind of Schrodinger CSS. It's got one input, two potential outputs. Col6 has one class, two potential permutations. It's been mutated, and this is hard and confusing to work with. And unfortunately, mutation is incredibly common in CSS. There are ways to get around it, though, especially with responsive stuff. Utility classes use these are what I call responsive suffixes, right? So we don't have one class anymore. We've got two separate classes. We've got call6 and call6 at small. We've got two inputs, two outputs. Don't worry about the mechanics of what's going on here. I'll share a link to this article after the talk. But the point I'm making is we're using two separate classes. We no longer have mutations. We're not mutating call6. We're inventing a brand new class to handle that change. Other examples, common example of mutations in CSS, things like this. So if we just take a quick look at this CSS and HTML, you may be able to spot a problem here. We've actually got a specificity mismatch. The class of text center has a lower specificity than subcontent h2. That means that this h2 is actually going to be aligned left. Even though we've put a class of text center on it, it's going to be text aligned left. This is a mutation. Because CSS operates in a global namespace and we have specificity, this conference has been sponsored by the word specificity, hasn't it? We've got this mismatch, right? And this is a mutation. Other parts of the code base can mutate and transform completely unrelated other parts. This is called a subtree collision, and it's caused by a greedy selector and higher specificity. We'll look at subtree collisions a bit later on. But parts of the code base are able to mutate other parts, unrelated parts. Gives us unpredictable outcomes, unusual side effects. And again, this is fixable. And true to form, it's an unconventional fix. The fix for this, stick an important on it. Huge caveat, never use important in anger. Only use important proactively. So don't use important to get yourself out of a specificity problem. If you're refactoring some CSS and the only way you can fix it is to use an important, well, refactor more until you don't need that important. But on utility classes, anything proactive, using important is actually advised. What this means is that a class of text center is always going to have a predictable outcome. Utility classes need to be immutable. We don't ever want text center to be text align left. Further examples of mutations in CSS. We've got a button, and it's got a certain font size on it, but when it's in the promo area, we want to increase that font size. We could use a selector like this, but the problem is we've got a mutation. We've got one input, which is class equals button, but we've got two outputs. We've got button and button if over here. The problem with this is that it's mutating button directly. Button has two potential states. Simple fix again, use another class, right? BEM is designed around not mutating things, but extending them. So immutability, try and avoid having several states of the same thing. We want to observe something fairly constantly wherever we see it. Use modifiers or responsive suffixes to provide this. Add important to force immutability. Again, only use important on utility classes. Don't use important in legacy or existing CSS, but apply it to any kind of utility class that only does one very specific job. And it's all about removing these states and conditions. And that brings us nicely onto the principle. I'm kind of cheating, actually. This isn't really a principle, but who's heard of cyclomatic complexity? Oh, cool, quite a few of us. Cyclomatic complexity isn't actually a principle. It's a form of static analysis. And cyclomatic complexity is static analysis that's run against a small piece of software, right? Usually a function, perhaps. What it basically does is it counts the, it counts the number of linearly independent paths through a program's source code. It's basically counting the number of decisions, or branches, sorry, on a decision tree. Kind of counting the number of ifs and elses. Very, very simplified way of looking at it. But cyclomatic complexity counts the number of potential outcomes stored in a function. There's an equation for working out your cyclomatic complexity, but unfortunately I've got no idea what it means. If you just remember that the amount of ifs and elses or potential outcomes of a function, the higher that number is, the higher your cyclomatic complexity. And as is the case with most of these things, we want it to be as small as possible. We want a nice small cyclomatic complexity because things become inherently simpler to work with. This is one of those ones where I do have to shoehorn this principle to fit CSS. But when I talk to clients, I tell them to study selectors in two parts. Oh, sorry, skipping ahead of myself. So yeah, we've got long compound selectors like this. We've all seen probably inherited selectors like this. Now people claim that CSS doesn't have logic in it. CSS isn't a programming language. There's actually a way of looking at this which is actually full of logic, full of if statements. What we're saying to the browser is, if we've got a div with a class of main, a section with a class of content, an h1 with an a with a span, then do this. Actually, because browsers read selectors right to left, we're looking at this. If we've got a span inside an a inside an h1, inside a class of content that's on a section, and so on, then do this. There are 7 if statements there. That's 7 chances for the browser to get something wrong, or for us to break something in the browser, not be able to match things. It's a much more verbose way of working. This cyclomatic complexity of this selector is really, really high. The reason it's high is because we've written just a bad selector. When I deal with clients and workshop attendees, I train people to look at selectors in 2 distinct parts. The first part is the subject. That's the only bit we actually care about. That's the bit we want to style. The span there is the only bit of this selector that we care about. The problem with a selector like span is it's going to capture a lot of the DOM. It's a very loose selector. So we have to write all of this complexity on the other side of it to narrow that search down. What we did is we started off with a bad subject and had to write very, very strict instructions to the browser to narrow down that search to be the exact correct thing. The solution to this, the fix for this, the remedy, is just to pick a better subject. Start off more explicitly. If you've got a little bit of color that needs changing on something, have a utility class that just colors something as a highlight. Don't write overly complex selectors that increase specificity and cyclomatic complexity and file size when you could just get straight to the point. Deeply nested or qualified selectors are bad news. These contribute to that higher cyclomatic complexity. Reduce these by using much shorter selectors. And when I say short, I don't mean the number of bytes, I just mean the number of component parts, so the amount of nesting or qualifying. And just try and start with the correct subject. I've got a real good example of this from a project that my friend built about 6 years ago. He knows I use this example. I'm kind of being a bit of a dick here by doing this, but he knows I use it. Because it's a really good example of finding a new tool and just going crazy with it. This is when he first discovered SAS. And all of his selectors were like this, just scoped exactly to the DOM. It led to this crazy long selector. Actually, what this is styling is one small link on the page, which could have just been like a class equals button that could have been moved anywhere. This is a symptom of misuse of tools. We don't really see this happening anymore. But this is a really, really good example of a high cyclomatic complexity. There are actually 12 different checks in this selector, 12 different if statements. And the craziest thing about this is the fact that I was refactoring this CSS, and that on its own still worked. All of this is complete dead weight. It's increasing the specificity of this selector. It's reducing its portability. The previous one, that only works, that styling only applies if we get 12 separate checks exactly correct, whereas this will work anywhere we put it. Also, it's just increasing file size. This is a real micro-optimization, but even the most intelligent minifiers in the world will never touch your selectors because it will just start to break things. So any bytes that are found inside your selectors are completely dead weight. And again, they contribute to this cyclomatic complexity and all the other problems that that brings with it. The next principle, the open-closed principle. Who's heard of this one? Okay, a few of us. Who worked in a legacy project or a project with lots of other developers? More of us. Cool. So this principle is really useful if you're working in like a hostile environment, either legacy or lots of other developers contributing at like a fast rate. You've probably experienced collisions, regressions, someone accidentally undoing your work, or someone writing something that affects a completely unrelated part of the DOM. These are all symptoms of like global namespace, et cetera, et cetera, et cetera, but there's a really traditional programming principle that can help us avoid these kind of regressions. Now, the open-close principle is unfortunately really poorly named because 50% of the useful information is missing from its title. The full version of it is that software entities should be open for extension and closed for modification. What also annoys me about this is that I have to remember which way around that goes. Like the title doesn't tell you which one's open and which one's closed to what. You have to memorize that. Open for extension, closed for modification. Picture the scene, right? You've got a, it's January, you're working on a product, you build some buttons, and you push them to the shared repository, and everything's fine. Then fast forward 6 months, people have been implementing your buttons, they've been using your stuff, and you decide that you want to change the padding on them, right? You want to change the padding on the buttons, and you do that, and you push that to the repository, and all of a sudden, things start breaking. The open-close principle tells us that we cannot change anything after it's been created. After we've created something and made it public, we cannot go back and change it because we get these knock-on effects. We get this domino effect of people's reliance on our bit of software is now kind of accepting these updates that they didn't necessarily want. It's kind of like semver or Git history. You shouldn't rewrite Git history because other people are now depending on that stuff. It's very, very dangerous to go back and change anything at its source. However, caveat to this, there is one time that we are allowed to go back and change something that already exists, and that's if it's actually a bug. A class can only be modified to correct errors. So if you made those buttons in January, and then in June somebody says, well, actually, Harry, you got these completely wrong, I'm allowed to go back and change those buttons because I made a mistake. There was a bug, they were incorrect. What I also have to do is be very diligent to go and check every instance of those buttons on the project and check that everything's still fine. That only happens if it's a bug. If somebody wants a larger button, for example, that's a changed feature or an additional feature, I cannot make that modification directly to the buttons. I have to write a subsequent bit of CSS that adds that functionality. This is the extension. And that class could reuse coding from the original class through inheritance. This is basically exactly how CSS works. It's an inheritance-based model. So yeah, taking the button example and sort of codifying it, we've built this button. Once it's out there, should not go back and change this. People are relying on it. People are expecting a certain behavior. We can't go back and modify this directly. But if someone needs a bigger button, they could just write something like this, I guess. Problems here are we've got a mutation, right? We're modifying the base button class. So it's been mutated. This is no longer immutable. We're modifying it. We're not extending it. And also, we've increased our cyclomatic complexity. So we've managed to get like a hat trick of bad things there. Real simple fix, just write a new class. Again, this is what BEM and methodologies like it were designed for. We can extend the behavior of button by adding this button large class. This is the changed or additional functionality that we were talking about. This is a way of extending features to make sure we don't regress anything, we don't accidentally step on anybody's toes, and it means that anybody who wants a larger button opts into it themselves. We're not saying that all the buttons are getting bigger, we are saying, I've exposed a new class so you can choose to have bigger buttons. It kind of gives us this contract between our HTML and CSS. This contract says that you cannot make a CSS-only change. You make a change in the CSS, you have to make the corresponding change in the markup before we get results. This contract between the HTML and CSS means that people implement your changes themselves. You don't implement them for them. Very safe way of dealing with legacy, prevents these regressions, prevents us accidentally undoing other people's work. Always build things forward, and like I say, it's a very safe way of working if you're in a big team, high rate of change, or you're working with a legacy application. If you inherit a legacy application, be very, very wary of modifying any existing classes. It seems counterintuitive, and it seems like it's going to bloat your CSS, and indeed it will bloat your CSS. But if you are maintaining a legacy product, try and avoid changing anything directly unless you've got a very good view of where it exists in the project or in the system. 9 times out of 10, you're going to be much better off. It's going to be much safer to create a brand new class and implement that in the HTML. And I think, finally, orthogonality. Who's heard of orthogonality? Cool, a handful of us. Orthogonality is quite a new one to me as well. Orthogonality basically states that it's the ability to use programming language features in arbitrary orders, arbitrary combinations, but still get consistent results. We should be able to pick and choose different parts of a language, use them in any order, and still get the expected outcome. We can again kind of shoehorn this into CSS. Orthogonality, if we can use things in random orders, it means that they obviously don't really depend on each other very much. If we can use things, completely arbitrary combinations, that implies there's a lack of interdependence between those modules. This in turn allows us to compose things better. We get much more composable systems if we can use things in random orders. Separates concerns by virtue of being interdependent. We're obviously not concerning ourselves with unrelated things. And it reduces collisions and removes side effects. Now, applying this to CSS is pretty simple. If you've got an existing project, the best litmus test for is your CSS orthogonal is, can I just randomize my imports? Can I shuffle all these imports around and recompile? If my view, if the UI still looks the exact same, you've got orthogonal CSS. You've got CSS in which the modules do not rely on each other to render correctly. So how well can we arbitrarily combine things? Can we arbitrarily combine them at all? If we can, the implication is they don't rely on one another. And this is a hallmark of a very flexible and modular system. If you're building a style guide or a UI toolkit for your product, you want to make sure that developers can implement things in completely random orders and still get expected outcomes. They need to be able to import the modal before the buttons and the forms after all of that, and still be able to build the exact same bit of UI. They need to be able to import the sidebar before the buttons, but the footer before the header and the header very last, and still get the exact same rendered view. This is a nice orthogonal modular system. Another good test for orthogonality is will it nest? This is testing orthogonality actually in the HTML. How well can we combine and compose things in the DOM? Can we put something inside of something else and both of them still render the same? The subcontent H2 versus text center example we looked at earlier, this is an example of non-orthogonal CSS. So well-scoped selectors help improve our orthogonality. Now this is unfortunately quite a difficult one to demonstrate, so I'm going to try and step through it fairly sensibly. I built a little demo here, and it's just a static HTML CSS build, nothing funky going on. And I want to style up this fun and vibrant city heading just there. Styled up using this C testimonial title, so it's using a class of testimonial title. But if you look on the right, promo H3 is actually leaking into that selector. The promo H3 selector is affecting the testimonial title. These are completely unrelated components. They don't have anything to do with each other. But we are getting what is called a subtree collision. Because promo H3 is a greedy selector, steps all the way down the DOM until it finds a match, it's actually grabbing the wrong bit of DOM, or rather it's grabbing extra bits of DOM. We can fix this quite simply, and it's just by avoiding using these nested selectors. By avoiding the use of promo H3 and scoping it to promo title instead, we can see that testimonial title is no longer affected by something further up the DOM tree. It's usually this example, so when people say, well, you know, I can just do nested selectors inside my component, surely. I don't want to put classes on everything. Maybe if I put a class on the top of modal and nest modal H1, modal A, modal UL, people often say that I can surely use fewer classes by scoping everything to a top level. That only gets you so far, because what happens when you move something unrelated into the modal is you open yourself up to the risk of these subtree collisions. So well-scoped selectors provide orthogonality. Just writing better quality selectors that capture less of the DOM, you're going to end up with orthogonal CSS. Right, we sprinted through quite a lot there. My time is up. I just want to say thank you for your time. It's been an amazing day. Anyone wants to be bored further by this, grab me for a beer later on. But for now, thank you very much for listening.